Welcome to Math Made Easy with EKN, and today we are going to be focusing on sequences, how to find the term to term, the position to term rule, and the Fibonacci code. So let's dive into things. We have 2, 4, and 6. Now the term to term rule is how long a number is from a number in a sequence. Well, to find it, we subtract the first two numbers from each other. Very simple, right? 4 minus 2 is equal to 2. So the term to term rule is what? Add 2. Now for the next one, we subtract the two terms. 6 minus 4 is equal to 2. And 4 plus 2 is equal to 6. Now by the term to term rule, it's not that hard. Now this is where the rule comes in. Now to find our position to term rule, let's say for instance in this, we don't have the next term of this sequence. So we write down the positions of our numbers 1, 2, 3. Guys, please give me 1 second, I'll be back. Sorry guys, I was just looking for some kind of question to give back to you, so we are going to focus on that question. So then we bring the position of our numbers, the fourth position. Now to find this, we are telling us to find the nth term. Let's say to me together, the nth term. Now to find the nth term, we need to get something straight to understand. Any number times the letter is equal to the number and the letter together, but the number comes before the letter. So if you have 3 times b, 3b, 4 times a, 4a, and lastly 5 times c, 5c. And solve it in the comments in the question for me. 6 times e, and put it in the comments. So now we bring it. Now that we know it and they are telling us to find the n term. Now the position of the number that doesn't have a term becomes the n term. So in this case, 4 is the nth term. And remember what we said, any number times and letter is the number and the letter together, but the number comes before the letter. So in this case, and we have to pick out our position, our term to term rule. Now the term to term rule is to add 2. So that's the first part of our position to term rule, 2 times the nth term, which is 4, n. We bring in that bracket. So 2 times n is now our position to term rule. We can test it out. So since we are supposed to find the nth term and n is the position of the number, then we can replace n with 1. So 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, and lastly 2 times 4 is 8. And that's our fourth term of the sequence. Very easy and very simple. So now let's go for another example, which I think is a very easy one. Let's say 4, 9, 14, 19, 24, and the next two terms of this sequence are all. So that's it. And for example, and first to find the position to term rule, we need to find our term to term rule. Very simple. We subtract the first two numbers from each other, which is 9 minus 4. So 9 minus 4 is equal to 5. And that's our position to term rule. Simple. Now to find out, sorry, that's our 10 to 10 rule. Now to find our position to 10 rule, very simple. We order our numbers with the positions. This becomes 1, 2, 3, 4, and 5. Remember, we don't have the next two terms of this sequence, so both of them become our nth term. Now we don't write it as nn. We still keep it as the same 1n. Now with our position to term, which is 5, very simple. So we put 5 times n, and we know how to do it. 5 times 1 is equal to 5, but in this case 5 times 1 is not 5, but it's equal to 4. That means something was done to it. And what was done to it? 5 times 1 is 5, and we know to get 4 we subtract 1, so 5 minus 1 is equal to 4. So now the position to tell me wouldn't be just 5 times n, it will be 5 times n minus 1. Now that's the position to tell me. So if you want to test it, you can test it out. So 5 times 1 is 5 minus 1, 4. 5 times 2 is 10 minus 1, 9. 5 times 3 is 15 minus 1, 14. 5 times 4 is 20 minus 1, 19. 5 times 5 is 25 minus 1 is 24. Very, very simple. Now we can use it to find the next two terms. Now 5 times 6 is 30, and 30 minus 1 is 29. And lastly, 5 times 7 is 35, and 35 minus 1 is 34. So you see, having to find the position to term is so easy and not so stressful. So if you are stuck in an exam, just remember this. We multiply our 10 to 10 rule by the position of a number, and if it doesn't reach, we know what to do. Either we subtract or add. So now, our last example on this, then we move on to our Fibonacci code. Okay, so our last example will be seven, 13, 19, 25, 31, and lastly 37. And for this, we don't know the next three terms. The first thing we need to do to find a position to term rule is to find that set to term rule is the most key thing in this. Now, to find the attempt to term rule, we know what to do. We subtract the first two numbers from each other, which is 13 minus 7. And 13 minus 7 is equal to what? 6. So we add 6. Now that is our term to term rule. Now we don't struggle now since we now have our term to term rule. Now that's where the real work comes in, as I always say. Now to find our position to term rule, we know what to do. We put down our term to term rule, which is 6. Then we multiply it by n, because we believe that's the rule for now. And then what do? We bring the position on the number. So 1, 2, 3, 4, 5, 6, 7, 8. Now we do the simple calculation. 6 times 1 is equal to 6. But in this, 6 times 1 is equal to 7. That's false. Now to make it true, we know what to do. If 6 times 1 is 6, then we know for sure 6 plus 1 is equal to 7. So now the new position to term rule is 6 times n plus 1. That's the new position to term rule. Done. So 6 times 1 is 6 and 6 plus 1 is 7. 6 times 2 is 12 and 12 plus 1 is 13. 6 times 3 is 18. 18 plus 1 is 19. 6 times 4 is 24. 24 plus 1 is 25. 6 times 5 is 30. 6 times plus 1 is 31. 6 times 6 is 36. 36 plus 1 is 37. And 6 times 7 is 42. 42 plus 1 is 43. 6 times 8 is 48. 48 plus 1 is 49. And lastly, 6 times 9 is 54. And 54 plus 1 is 55. So those are the last 3 terms of this sequence. Now, lastly, we are come to test for the Fibonacci code. So now let's say we have 4, 8, 12, 20, and 32. And we don't know the next 2 terms of this. Sorry, the next 4 terms of this sequence. Now the Fibonacci code, here's how it works. Now, to find the Fibonacci code, you add 2 numbers of the sequence together to get the next 2 numbers. So 8 plus 4 is 12. That's the first. Now to get 20, we add the next 2 numbers. 12 plus 8 is 20. We know now that's what I said. 20 plus 12 is 32. So we add the next previous the new number to the previous number to get the next number. 20 plus 12 is 32. Now to find our next sequence, 32 plus 20 is 52. Now 52 plus 32 is 84. Now 84 plus 52 is 136. And lastly, 136 plus 84 is equal to 220. And the sequence goes on and on. So the Fibonacci code is actually not that hard to find. Now for our last example on the Fibonacci code, I'm going to make it a little bit tricky for you guys. Okay, now finding the Fibonacci code should be easy. 7 plus 4, 11. 11 plus 15, that's the missing thing. Now to find the Fibonacci code, we reverse it, and I call it like the whole word backward. So like the inner beef code, kind of so. Then we subtract 45 from 15. 41 from 15. So 41 minus 15, 3, 11, so 6 is 26. So that's how you find this. And to make it true, 26 plus 15 is 41. So there you have it, how to find the term to term rule, the position to term rule, and the Fibonacci code in this sequence. Don't forget to hit that subscribe button for more videos from my feed. Until we meet again, peace.